The empty set, or sometimes we call the null set, is the set that contains no element or no member. It does make sense, right? Empty set, if you think about set as a group, empty group, that means no member in there. And the notation to represent the empty set will be the set notation with nothing in there, but you just write them next to each other, or the null symbol. So I'm going to write here. So this is as a set notation, and this one is the technically another way we call it is the null set. So a quick and easy way, curly bracket open and close because we don't have any member. That's it. Or just 0 and then cross it. Okay. But if you put them together, it doesn't mean that represent an empty set, because if you look at the portion here, you open the set, you close the set, but you see something in there. This one means this set has one member, and that member is the notation empty set. So this is not empty. Okay. Make sure that nothing in there to be called empty set. Whatever, at least something within or in between the open and the closed curly bracket, that set is not empty anymore. For this example, we're going to determine which set represents the empty set. For example 1, as you see, you have the curly bracket, the open, okay, open, and then close. You see something in there, and that something is the number 0. The conclusion or the solution of this problem that is not an empty set. So the reason why it's not empty, because it contains one member, and that member is the number 0. Okay. The next example, you are given in the set builder notation because you have the set symbol, you have the vertical bar here as before the vertical bar. That is the notation for the member in general. And after the vertical bar, that explains the property or the description of the member that they have in common. To be safe, if you have this kind of situation, you can kind of pretend like if you make a list or you do the roster technique or the roster method, what are members that you can identify based on description that provided? For this problem, X such that X is an integer. That's a property, integer. Integer means like number -3, 0, 1, 10. It could be negative or positive, but it has more description that X is strictly greater than 3. Think about the number as an integer greater than 3. Greater than 3, we can say, okay, it's going to be 4, it's going to be 5, it's going to be 6. And another common property of these members, it has to be less than 7. That means we cannot include 7. We cannot go anything greater than 7. That's all we can have as a member. As you represent the set in a roster form, you open, you close, and you see something contained in there. Definitely not empty. So we can say this is not an empty set. Okay, and then the next one, similar way, if you look at the members or kind of make a list if you could, X as an integer similar to the number 2 and X less than 2. Okay, anything less than 2, we can think about the number 1 or 0, -1, -2, and so forth, right? But another common property, those numbers has to be greater than 10. Can you find any number that at the same time less than 0 but greater than 10? Well, we cross out. That's not. So nothing that we can put in. So we ended up with nothing in the set notation. This case, we can say this is an empty set.